Hello, geometry. This is 11.4, three-dimensional figures. We kind of get a break from the formulas that we've had last two, and just kind of some terminology and some recognition of the vocabulary and some new names and shapes that we can use for some three-dimensional objects. So what we're looking at here is something called polyhedron or polyhedra, and those are basically three-dimensional objects. And we're going to look at how they are named, their cross-sections, and what happens when we revolve two-dimensional objects around an axis. Okay, so there are five what they call Platonic solids, and these five. They're kind of your five most basic three-dimensional shapes. There are a lot of background to these that we won't get into right now, and I'll have to kind of review that as well. I know it's there, I just don't remember it right now. What I want to look at is how you can use a lot of the parts of the names to figure out what the shape is. Now the cube is a unique one because it has a name that doesn't include the word hedron with it. Okay, hedron basically means faces. It has faces. It has sides. So it's going to be a three-dimensional object. Tetra is a name for four. Okay, so if you look at this shape right here, the tetrahedron, is made up of four triangles. It's made up of four sides. Okay, those sides are called faces. Okay, so the face is what they're talking about here. The face, think of it as kind of the side. And in order for it to be a hedron, it has to be a polygon. Okay, we'll talk about that later. What makes a hedron, what doesn't make a hedron, or they'll say hedra. Okay, so the face is a side and it has to be a polygon. Okay. The other part that we have here is the vertice. So a vertex is, think of a corner, but it's not a corner here. That's going to be an edge. Okay, so this right here and down here, those are examples of vertices, where the points are. So those are vertices. This right there or right there, those would be examples of edges. So if I have a tetrahedron, the number of vertices I have would be 1, 2, 3, 4. I have 4 vertices for that down here. 4 vertices, page 329. The number of edges I have would have 1, 2, 3, 4, 5, 6. I'd have 6 edges for a tetrahedron. Okay. And the number of faces is back to 4. I have 4 faces. I have 3 kind of on the top, then I'd have a base. For a cube, the number of vertices, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 edges to a cube. Okay, if you take imagine this is a cube. It's not a cube, but you'd have 1, 2, 3, 4, and then you have 4 around the wrapping, and then the 4 around here. Okay, so we have 12 edges. Number of faces, I have the front and the back, and then I have 4 around the side, so I have 6 faces. Okay, let's do one more, then I'm not going to take the time to count the rest of them. An octahedron. Octa, the prefix there, means 8. So this has 8 triangles. So this is 8 triangles. Tetrahedron is 4 triangles. A cube is 6 squares. Okay, let's keep looking at dodeca. Dodeca is 12. So this is made up of 12 pentagons. Icosahedron, that has triangles 2, 3, 4, 5, 6, 7, 8, 9, 10, 21 maybe. I don't know. I have to count on that. I'm not going to take the time now to do that. Octahedron, go back to that. Octa means 8. So how many vertices? We have 1 on top, 1 on bottom. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 6 vertices for an octahedron. Edges, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Faces, 1, 2, 3, 4, 5, 6, 7, 8. 4 on top, 4 on bottom. Okay? So faces, edges, and vertices. Be able to recognize the difference between those. Okay, here's all your terminology. A polyhedron. We'll see this on the picture. an object made up of polygons. Okay, an object made up of polygons. Basically think no curves. Okay, polygons are like squares or triangles or hexagons. Okay, so those are examples of polygons. Not a polygon is a circle. Circle is not a polygon. Okay. The face is a flat surface. The edge is where two faces meet. And a vertex is where three or more faces meet. They're going to be your points. A cross-section is what happens when you slide a plane through an object. Okay, so we're going to see that here. These are cross-sections. Okay, so if you have a three-dimensional object and you take a slice out of it. Okay, so cross-section is when you slice an object. So imagine if you have an orange and you slice it in half, that's a cross-section. You can look at what shape you have there. Solid revolution, axis revolution, we won't see a whole lot of that. But that's, I guess we'll see it some. Solid revolution, rotating a two-dimensional object around an axis. Around an axis. Okay, so you're going to have axis symmetry, and you're going to have something that's a two-dimensional object. So if I have, imagine this is a square. Oop, didn't mean to blind you with that. Okay. There we go. This is a rectangle. This is my axis. If I take this rectangle and I rotate it around the axis, I'm going to end up with a cube. Okay, so imagine it's making, like a 3D printer, it's making its object as it goes around. You'd have a circle along the top, and then you'd have the outside of it, then have a circle along the bottom. So you'd have a cube out of that. So taking a solid revolution is taking something that's flat and rotating it around an axis and getting a three-dimensional object. Three-dimensional object. Axis of revolution, this is a line that you rotate an object around. A line that you rotate the object around. Okay. So these are your polyhedra, and not polyhedra. Okay, we have prisms and we have pyramids. Now the difference between a prism and a pyramid is how many bases you have. Okay, a prism has two bases. It has a top and bottom. A pyramid only has one base. Okay, so prisms and pyramids are your two types of polyhedron. They are both named off of the shape of their base. Okay, so this prism here has a rectangular shaped base. Its base is a rectangle. So this would not just be called a prism, we could call this a rectangular prism. Okay, so if you have something that might be a, try my best at three-dimensional drawing here. Okay, that's the back right there. Okay, so this would be a prism because we have a top and a bottom. The bottom here is a pentagon, so we would call this a pentagonal prism. Pentagonal prism. A pyramid would only have one base. If this is a square, let's say this is a square, we would just call this a square pyramid. If it was not the same length and width, it would be a rectangular pyramid. Okay. We can draw a that should be dashed back there. Let's try that again. There you go. If you can see it, there's my base down here. It's going up to a point. This could be a triangular prism. Okay. These are not polyhedron. You notice the curved surfaces, cylinders, cones, and spheres. They are not polyhedron. Okay. So tell whether the solid is a polyhedron. That means, is it made up of polygons? So it has to be made up of polygons. If it is, name the polyhedron. Okay. So here we have, this is not a prism or a pyramid, but it is one of our polyhedrons. It's one of our original ones. We have 1, 2, 3, 4, 5, 6, 7, 8. We have an octahedron. An octahedron. This is not a polyhedron. Okay, so it has to be made up of squares, triangles, all those. I wanted some more examples of this. This is one website I found. This kind of goes through, here's your Platonic solids. It tells you how many of each of these. Oh, icosahedron did have 20 equilateral triangles, 30 edges, and 12 vertices. Okay, dodecahedron, cubes. And then down here, here are your prisms and solomons. Prisms and solomons. Prisms and pyramids. Okay, you notice this first one, they're all prisms. They're going to have two bases, top and bottom. Okay, your pyramids will all have one base, and they'll come to a point. If there's a point, it's probably going to be a pyramid. Okay, the nets, which we won't talk about, that is if you take the three-dimensional object and break it out into its pieces. That's what's called a net. Okay, and if you can fold along these lines, you'll get these shapes back. Okay, so prisms and pyramids. So name the figure based on the shape of its base. So here, this would be a prism because it has a top and bottom, and we have 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. So it'd be a heptagonal prism. Heptagonal because there's 7 sides. The heptagon, so it's heptagonal prism. This would be a square prism because you have a square on the bottom and it has 2 faces. This one, 1, 2, 3, 4, 5, 6. That's a hexagon, so this is a hexagonal prism. This one is not a prism, it's a pyramid because it comes to a point. And we have 1, 2, 3, 4, 5, 6, 7 again. Heptagonal, I had to think about that. Heptagonal pyramid. So still, this is a heptagonal prism. This is a heptagonal pyramid. Another prism, hexagonal prism. 1, 2, 3, 5, 6. Hexagonal prism, same one. A pentagonal prism. 1, 2, 3, 4, 5. 5 sides, and it's a prism. Rectangular prism. This one, 1, 2, 3, 4, 5, 6, 7, 8. That would be an octagon, so it's octagonal pyramid. Okay, so hopefully that makes sense on how you're doing those. A little breakdown of prisms and pyramids again. Okay, prisms have the 2 bases, pyramids have 1. Prisms will have rectangular faces. Okay, going around it, they have rectangular faces. Pyramids have triangular faces. They're all named by your bases. Okay. So when you describe the cross-section formed by the intersection of a plane and a solid, they just want to know, okay, what shape is formed here? So if you cut this right here, you would have a square. So the square is formed. Okay, if you cut it right here, you'd have a triangle. That'd be a triangle. This one, how it's cut here, notice, remember, that's sloping out, that's sloping out. This would be a trapezoid. Okay, they're going to give you the image, you kind of figure out what shape it's showing here. Okay, this is the base. The base has a 1, 2, 3, 4, 5, 6, 7. What's up with 7 in this assignment? That's a heptagon. Okay, so you may need to go back and review all of the names of your polygons. Okay, Finally, sketch the solid produced by rotating the figure around the given axis. Then identify and describe the solid. So what we have here is we're going to take this trapezoid, and they want us to rotate it around this axis. So we get to use our imagination, and we get to think about, okay, what kind of shape would be formed if I rotate it around? I'm going to think of it more like this, because that helps me go left and right. So if I rotate this around, see how I draw that? Going around, I have a top and a bottom. So I have top going down to a bottom, and that'd be the back over there. The radius down here would be 4. The radius up here would be 2, because there's the 2. There's the 4. And the height would be 8. So we have looks like we have a portion of a cone, kind of how we can describe that. The radius on bottom is 4 centimeters. The radius on bottom is 4 centimeters. The radius on top is 2 centimeters. And our height is 8 centimeters. For this one, I'll go back here. I like to have my axis vertical. So if I rotate this around, I'm going to kind of just draw a circle, rotate this around. There'd be the top, there'd be the bottom. So it looks like we have like a circus tent. That'd go around the back. So right here, if I had a rectangle, if I rotate a rectangle, I get a cylinder. If I rotate a triangle, I get a cone. So if you rotate a triangle, you get a cone. If you rotate a rectangle, you get a cylinder. Okay, that will be helpful when you get to the assignment. So we have a cone on top of a cylinder. The radius would be 8 centimeters. So the radius is 8 centimeters. The height would be 4 centimeters. Okay, and this out here would be 2 centimeters from that. Okay, the shapes you're going to be seeing aren't going to be quite that complicated, and that goes to 11.5. Okay, on your assignment, you're going to start with just naming the polyhedron. So look at the base, and then if it comes to a point, it should be a pyramid. If there's two, a top and bottom, it should be a prism. Okay. Now this is laying down. Remember, the base would be this bottom one and this one up here. This is not a pyramid. That one was not a pyramid. Okay. Tell whether the solid is a polyhedron. If so, name the polyhedron. Remember, you're looking for things that are curves. If it has curves, it is not a polyhedron. Okay, stand that one up on its end. Okay, here's naming the cross-section. Cross-section of a cylinder, cross-section of a rectangular prism, cross-section of a cone. Okay, identify and describe the solid produced by rotating the figure. This is a square being rotated around an axis. Okay, square rotating. And you state what the height is and what the base radius is. There's a big hint that you have a radius. This is a triangle being rotated around an axis. A semicircle being rotated around the axis, and then another rectangle. Okay, and that should cover it for that. Okay, 11.4, I think we've got about 4 or 5 more assignments, and we are wrapping things up. Good work. 1, 2, 3, 4 more. All right, I'm going to try to get those done this week. It's the week right after Easter, and then I can be available for answering questions more or whatever you have. So, but I guess you guys are doing well. Hope you're staying up with things. Hope you're doing well, and miss you, and we'll hopefully see you soon.